so incrementally small.
Yeah.
It's only over large distances that it makes any difference whatsoever. So
It's ironic that you mentioned that. I was along the theme of a red light warning multiple days.
really,
How did your bullshit detector do all this stuff?
exactly.
If we could just harness that energy, just a portion of that whole turn.
Yeah, absolutely. It'd be amazing if we could do that. That's like saying, you know, oh, well, if we don't just figure out how to use gravity on Earth to power things. It's like, oh, we could, but they'd have to continuously fall forever. You know, and we have to figure out how to convert the kinetic energy into, you know, I mean, it's possible to convert gravitational potential energy into actual energy, but that's usually as it falls and when it hits us. So,
For sure. Well, Isaac, thanks for your preparation and your work.
absolutely. And I hope it's entertaining. It has music and everything.
The whole package.
Whole package.
Did you get to sleep?
Well, I actually, I'm not, I wanted to, it's not like I could be here, I wanted to get out, so I took the monorail. I went to downtown, and then back to the hotel.
I was just thinking that my bet was for most of the students, especially folks who are visiting here, that we're going to an event. 10 o'clock is a bit of a difficult.
Yeah, actually, I am. I have to run the Armstrong in the dam. Yeah, no, for real. And we're like, wait, you can play this. He's like, Sure, I can do that. We've been relying a lot on, like, everybody down there, like, sending people is this, and reception people is this, and from the two people is like, to go, group alone. Yeah. And I had to think that goes wrong, and I had to go and wish I never showed up, and people are like, oh, I thought my hours were at 7.
Team building exercises and this challenge course. We had a class on food preparation. Basically, we were taught on how to prepare meals from shelf-stable ingredients. We had our airways tested to make sure that there was no congestion or blockage, anything that would affect this experiment. And here's a sample of some of the meals that we prepared using shelf-stable ingredients. This is a selection of sushi right here. This is a picture of the crew that was selected for the first high seas mission. From left to right here, Angela Vermeulen, our commander. He is from Belgium. Cyan Proctor, many of you know Cyan. She was our public outreach officer. Also in secondary roles, she was a photographer and a geologist. In the middle is Jahaira Sierra. She was our science officer, also a microbiologist and a material science scientist. Then myself, here I was the crew geologist, but I was also the health and safety officer and an IT or information technology officer. And Kate Green, second one from the right here, she was our crew journalist. She also coordinated our sleep and exercise routines. And finally, Simon Engler on the right. He was our engineer and roboticist. After the crew got selected, we did a 2-week training mission at the Mars Desert Research Station in Utah. This was essentially a dry run for the high seas mission. This took place in January of this year. And here's the 6 of us with the Habitat in the background. I know many of you are probably familiar with this facility. Basically, it includes a 2-story cylinder that's about the right size and shape to fit into the fairing of a Saturn V type rocket. So this is basically what Robert Zobrin has envisioned as a habitat that would land on Mars and provide facilities for a couple of years for the crew to live on the surface of Mars. And there's also an attached greenhouse that is used for growing plants. And we did some of that in preparation for Hawaii, because that was one of the experiments there as well. Let's see. This picture right here, it's called rhinomanometry, basically testing the pressure that's exerted when you breathe in and out, and that tests how clogged or congested your airways might be. Here, this is odorant identification test that I mentioned before, basically identification of mystery odorants in these containers. Then we practiced for analog EVAs, essentially going outside and doing field work, wearing simulated spacesuits. So we're doing geology and microbiology under these types of constraints. And here's Jahaira in the lab area of MDRS. Here's Kate and Jahaira in the kitchen, and there's Cyan in the kitchen right there. After MDRS, the next step was to actually go to Hawaii. But before we started the high seas mission, we had about a week and a half of training and preparation and cultural activities and orientation. And we were also trained on the various systems in the habitat and how to use them properly without blowing the place up. Here's a bunch of us in a big lava tube on the big island of Hawaii, basically doing geological training and getting an introduction to the geology of the big island. a bunch of us with a Hawaiian priest who provided a blessing for the mission. We also volunteered for this tree planting, a reforestation project on the slopes of Mauna Kea. We visited the facilities, telescope facilities on Mauna Kea. So it was quite a full week of activities. Then we actually arrived at the habitat, and this is what it looks like. We arrived at night. So that was, I think this picture was in fact taken by Cyan on the first night that we arrived. This was our first glimpse of the habitat. It's a geodesic dome, about 32 feet in diameter. This is what it looks like during the day. It was designed and fabricated by Blue Planet Foundation, which is run by Hank Rogers. That name might be familiar. He is the guy who basically not invented, but popularized the game Tetris, made a lot of money off of that. It's a small, self-contained and portable habitat. It's located at a disused quarry about 8,000 feet on the upper slopes of Mauna Loa. It accommodates 6 crew members for basically up to a year. The total square footage of the habitat is about 1,000, roughly. It's isolated with very little plant or animal life nearby, so it's a very Mars-like environment. And that provides a lot of opportunities for relevant field work, such as geology, microbiology, robotics testing, and so on. Very, very realistic representation of the Martian surface. The next couple of slides show the floor plan of the habitat, so you can have a feel for what it looks like inside. On the left here, this is the first floor of the habitat. This is our common area that was used mainly for exercising. We had a common workspace area set up here, although often people just worked up in their rooms, and this area ended up being used mainly for storage. We had a dining room that also doubled as a conference room here that we spent a lot of time not just eating there, but also having meetings. And we had a pull-down screen that we used and a projector there in that area. There is the kitchen that was quite large and well equipped. This is the picture of the kitchen facilities. And here a bunch of us are sorting through all of our supplies for the 4 months, basically conducting a very thorough inventory of everything we have and dividing it into bins, basically one bin for each month, and making sure that we have everything is properly rationed and we have enough food and supplies for the 4 months. Also downstairs we have a small laboratory area and a bathroom. And here we have a storage container that's basically used, also was used as a work area and a robotics garage. This is the second floor of the habitat. Basically, it's just our bedrooms on the second floor and another bathroom that was also located on the second floor. This provides an overview of the site around the habitat. This is an aerial photo that I took myself of flying over the habitat. So this is what it looks like from the air. Here's a list of the infrastructure that's around the habitat. So we have our main and backup water tanks located right here. We have our solar water here, which worked wonderfully, providing us with hot water on demand, and that was located on the roof of the storage container. Then we had our septic tanks and gray water tanks right there. We had our generator, and here's also a picture of that generator, providing up to 20 kilowatts of power on demand. Most of the electricity came from solar panels, but it also had a diesel mode basically as a backup and in case a lot of power was required after sunset. We also had a weather station and various telemetry and communications systems. And actually this right here is the primary antenna for our communications. And speaking of communications, that's the next slide. We had basically 2 communications channels. We were right here, so we had this direct link to NASA facilities on the slopes of Mauna Kea. And we also had this secondary link that was used mostly for telemetry that was bounced off MLO, or Mauna Loa Observatory, and then up to HPA, or Hawaii Preparatory Academy. And then they would pass on the telemetry that was coming from the Habitat to mission support. Now is probably a good time to quickly mention mission support. It was a 2-tier structure. So the first tier was staffed by volunteers, and they provided our basically first line of support. If we had any questions, we needed something researched, something wasn't working right in the habitat, we would contact first tier mission support, and they would work out a solution for us. In some cases, however, they needed to pass on the query to second tier mission support, which was basically project principal investigators, co-investigators, people who were really closely involved with a project and who could make more difficult decisions if needed. And we had a 20-minute communications delay imposed on emails that were sent out back and forth. The 20-minute delay did not apply to telemetry. Telemetry was received live. And speaking of telemetry, here's all the sensors that we had in Habitat. We had a weather station, water level sensor, which allowed us to know exactly how much water we had in the tanks outside without going out there and looking. We had CO2 sensors, temperature sensors, humidity sensors, power sensors. All of these sensors, most of them, updated at 5-minute intervals, and we could easily basically see the status of everything in the habitat just by going to a specified IP address and selecting whether we wanted the power status or the status of the water or temperature, CO2. Here's a plot of the CO2 levels in the habitat throughout the day. And actually, I think I have another one of these on the next slide that you'll be able to see better and see how it corresponds with our activities throughout the day. And as I mentioned, this telemetry was monitored by mission support in real time. So this is a plot of CO2 levels in the habitat throughout the day. So here, basically everyone's asleep. Levels are pretty low in the middle of the night. Then when people wake up, levels start climbing, and they basically reach a peak during our morning workout routine. So we're putting out a lot of CO2. We did have basically a system that would remove CO2. We had a ceiling vent and a ceiling fan that would be coupled to CO2 sensors. So if CO2 levels got too high, that fan would spin faster and faster and remove the CO2 from the area. But sometimes it had a little bit of trouble keeping up, as you can see here, during our exercise routine. Then basically after breakfast, CO2 levels would drop back to their baseline levels. This provides a very quick summary of some of the research that we were doing during High Seas Mission 1. We basically had 3 different layers of research. There was our primary study, which was, as I mentioned, a study to investigate different strategies for long-term, for food preparation for long-term exploration missions. So the 2 strategies that they were investigating were basically using instant pre-prepared meals, kind of like what the astronauts are doing right now on the International Space Station. You just add hot water and there's your meal. And the other strategy involves allowing the crew to prepare their own meals from shelf-stable ingredients, which of course it requires more time, requires more resources, but the benefits might outweigh that in terms of crew satisfaction, crew morale, and crew productivity. So they were basically tracking how many resources would be used for each one of those strategies and what the benefits were of both of those strategies. So in addition to our primary study, we also had research projects that were led by individual crew members. And some examples of that were a sleep study. We had to wear sleep monitors every time we went to bed, for example. A robotic companion study that was run by our crew engineer. Telerobotics study. They were operating a remotely controlled space farm from the habitat. That was Simon's and Angel's project, and we also were operating a remotely controlled rover in Toronto, Canada, in collaboration with the Canadian Space Agency. Basically, kind of like remotely driving a rover on the surface of another planet. And thermography, that was my project. I'll show you some results from that. And hygiene monitoring, that was Jahaira Sierra's project. Basically involved studying food spoilage under mission conditions and bacterial loads on various surfaces within this self-contained habitat. And finally, the last layer of research was opportunistic research. This was research that was proposed by outside investigators that we conducted for them. And examples of that include the exercise study that we did for NASA, antimicrobial textile study and evaluation that we did for Cupron, and this thing called SIFT that involved automated analysis of all text-based communications. So for that, they were analyzing emails that were going back and forth, and also they asked us to journal and had their automated computer algorithms analyze that. And if you'd like to know more about the research that was done during that mission, here's the link. The website is basically, it's highseas.org, and it contains a lot more information about this. So as promised, here's one of the results from my thermography studies. This shows 360 by 180 spherical panorama of the habitat. So this is the main floor of the habitat. This is what it looks like. This is our work areas slash storage space. Here's our dining room and conference room. There's the kitchen right there. Here's some exercise equipment. This is what it looks like in infrared during the day. Red represents warm temperature. Blue, violet represents colder temperatures. So you can see how the temperatures are distributed and how basically there is a temperature gradient from bottom to top. Warm temperatures are concentrated near the roof of the habitat. Looks quite a bit different at night. So this is what it looks like at night. The temperature scales here are different, so this does not mean it's the same temperature here. This just provides you a sense of how temperatures are distributed. So now there is no temperature gradient along the wall, but heat is getting trapped right here. And the rooms are the warmest place, basically, at night, as they should be. I was just very quickly going to show how temperatures vary throughout the day. So these two panoramas were taken just 1 hour and 15 minutes apart. And you can see how temperatures are getting cooler as the afternoon progresses. And this is a thermal panorama of our storage area of the shipping container. On top, it's thermal infrared. On the bottom, it's visible for a context. So we were basically using this as a storage area for our food supplies. So we wanted to put our food in an area where it would be kept at cooler temperatures to reduce the possibility of spoilage. And this kind of thermal monitoring and assessment provided us with that information and also assured us that temperatures were safe for food storage throughout the day. So once in a while, we went outside the habitat to do field work. And in order to go outside the habitat, we had to wear simulated spacesuits. These suits here were provided by Space Systems Lab at the University of Maryland. They're called MX spacesuit simulators. The total weight of the suit, including the backpack, is about 50 pounds. So it provides a fairly realistic simulation for what an actual spacesuit would feel like on a planetary surface like the moon or Mars with lighter gravity. The backpacks of the suit, they basically contained a battery unit, a unit for liquid cooling. So we wore liquid cooling garments to keep us cool underneath the suit. And they also contained a system for air circulation within the suit. Here are some pictures that were taken outside using my thermal camera. This is an entrance to the lava tube in the early afternoon. So here it is, the same panorama in the visible, and you can see how the temperatures change as you go away from the entrance to the lava tube. And this provides an easy way to remotely identify lava tubes from aerial vehicles or from orbit. And here's basically the same thing, smaller lava tube entrance, and you can see how there is a cool spot right here associated with this entrance to the lava tube. Since this is a space habitation and medicine panel, I thought I'd mention a few things about my role as the HSO, or Health and Safety Officer, on the crew. Before we went in, we had several types of medical screening. One of the requirements for the application was the ability to pass an FAA Class 2 flight physical, so everyone in the crew had to go through that and pass that. We also had blood tests done to make sure that our blood chemistry, all the parameters were normal, and each one of us had a personal interview with our CMO, or Chief Medical Officer. That was Dr. Joseph D'Angelo. He is one of the co-authors on this talk. Before the mission, health monitoring protocols were established. We had a system whereby I would write weekly reports to the Chief Medical Officer on the health and well-being of the crew, also noting any issues of morale. And crew members could also contact the CMO if it was a sensitive issue, or if they felt like they did not want to go through me for whatever reason. But most of the time, I was the eyes and ears of our flight surgeon, of the CMO, and it was basically my job to observe and make sure that everyone was healthy and reasonably happy on the crew. We had protocols for both non-emergency and emergency responses. We had a very well-equipped first aid kit on the site, and we were allowed to break SIM anytime it was needed for safety reasons. This only happened once during 4 months when we were outside an EVA, and one of our crew members was exhibiting symptoms of heat exhaustion, and at that point, basically, I instructed that person to remove their suit and walk back to the habitat without the suit, because there was very clearly a problem there, and I did not want to get it any worse. But that was the only time we broke SIM. That was the only fatality we had in this mission. The Chief Medical Officer was always there to provide guidance and support if needed. For the emergency response, the local emergency medical services were aware of our existence. They knew where we were. They knew how to get to us. We selected landing zones for a helicopter near the habitat in case it came to that and people had to be evacuated by air. And if an emergency were to happen, it would be my responsibility to administer emergency care to the extent of my training. I'm a wilderness first responder, so I have been trained in providing emergency care and arrange evacuation, basically make sure that emergency services are called and arrange the proper method of evacuation for a given emergency. And here's a list of the medical equipment that we had there for routine care. Basically, as I mentioned, a very well-equipped first aid kit that contained everything that you can imagine in a first aid kit. We also had personal first aid kits, a very long list of over-the-counter medications for every malady imaginable. We had a blood pressure cuff to measure blood pressure, stethoscope, glucometer to keep track of our blood glucose levels. Ankle braces were basically mandatory when walking outside because we were walking on really rough terrain, lava fields. We did not want any twisted ankles. We wore exercise monitors. It was basically an armband that we wore pretty much 24 hours a day, taking it off maybe just once a week to recharge and clean it. So that provided a very accurate record of our physical activity in the habitat. And finally, we had blood tests done several times during the mission. Since I'm not personally qualified to draw blood from the vein, we had a technician come over, and they would basically sit in the airlock area, and we would put an arm through, and they would draw the blood from our arm. So there would basically be a screen, a partition between us and the technician, so we'd never actually interact with the other person. And for emergency care, we had several prescription medications that were basically under my control to distribute if needed in case of an emergency. We had a telephone that could be used to call for help that was basically only for emergencies. It was sealed. We were not allowed to use it for any other reason other than for serious emergencies. We had splints in case of broken bones. We had a backboard to be used for evacuation, and we had a defibrillator. This should give you some sense of what our daily routine was like at high seas. On the left is our daily schedule. We wake up pretty early, around 6:45. On some days, we would receive a light dose for the sleep study. Basically, the sleep study involved periods where we would receive a dose of bright light for 45 minutes a day, and then basically various performance assessments and surveys to see how that bright light might affect us throughout the day. We had our daily exercise routine and basically getting ready for breakfast. Breakfast at 8:30, morning meeting after breakfast. Then we had some time set aside to do our personal research or go out on EVAs or do chores. We all had assigned chores to do in the habitat. Then some people did their exercise later in the day. Most of us did it in the morning, but some people preferred to do it later, particularly if you were receiving a 45-minute light dose, you might prefer to do your exercise a little bit later. Then we had our lunch. Well, we had a lunch prep period. We had our lunch at about 1 p.m. We had another block of time set aside for our research, EVA, or chores after lunch. Then it was time for dinner preparation, and then after dinner we'd have a lot of surveys that needed to be done, reports, logging the recipes that were used throughout the day if it was a cooking day. Free time, we didn't really have very much of that. So for free time, let's see, we had 2 movie nights a week, and that was pretty much it. We had some games in the habitat that we never really touched because we were so tired, usually towards the end of the day, and there were so many things that needed to do. Watching a movie was about, all that we had brain power left for. And then quiet hours started at 10 p.m. This, I'm not sure if you can make this out. I'll point out the main parts of our weekly schedule. We had a rotation set up whereby each day would have a main cook and an assistant cook, and those people would be responsible for preparing meals. Other people would be responsible for making bread, doing dishes. We had a schedule of scientific tasks that needed to be done on a regular basis. These included nasal patency tests, odorant ID tests, performance tests that we had to do, meetings, deadlines, and we also had assigned chores. And this is the next to last slide. It just shows some pictures illustrating the daily life in the high seas habitat. So here's Jairo and Angelo preparing a meal. Here's Simon and Kate. Here they're remotely operating a rover for the Canadian Space Agency on a simulated Mars terrain in Toronto. Here's Angelo. He is wearing this armband that I mentioned before that tracks all of his physical activity, and he is breathing into this mask to test his airways. Here's basically what part of the exercise period looked like. We were required to exercise at least 1 hour a day, and that included both aerobic exercise and strength exercises, basically weightlifting. We primarily used rubber bands or body weight for that. Here is basically the one and only porthole that we had in the habitat, our window on the outside world. Very popular. People spend quite a bit of time at that window. This is the DVR. Basically, we had 4 cameras in the habitat that recorded our activities in the dining room and the kitchen. So now we have hundreds of hours of footage that some unfortunate student or students will have to go through and extract data from. They're interested to basically see how much time each individual crew member spent preparing meals. We had a 3D printer in the habitat that we used to print spare parts for things that broke. That was a very useful appliance. We had to fill out about 12 different surveys per day. Here's one of those surveys. Every time we ate a meal, we had to fill out a survey evaluating basically how hungry we were, how appealing the food was, appearance of the food, smell of the food, taste of the food, all of that. So that's what that looked like. We had several robotic companions. That was a study that was done by Simon Engler to basically evaluate whether robotic companions can be used as pets on long duration space exploration missions. And here is Jahaira wearing a sleep monitor. So every time we went to bed, we had to wear those to track our sleep. And that is basically my presentation. I'll leave the acknowledgement slide up, and I'll take questions. Thank you. Go ahead.
All right, thanks. You had spoken a little bit about the sleeping arrangements and how you had your separate sleeping quarters, but could you talk a little bit more about some of the sleep studies that you were doing, or any differences, I guess, in your sleeping arrangements to kind of serve as an analog for what you might experience if you were in the Mars environment or something like that? So how were your sleeping quarters set up, I guess? Was there anything that was different with that?
Okay, so we each had an individual bedroom that was pretty small and did not provide very much in the way of sound insulation, unfortunately. So when you were in one of those little rooms, you could basically hear everything that went on in the rest of the habitat. So that was one of the reasons why we had quiet hours that started at 10 p.m. To basically allow people who wanted to go to sleep at that time a quiet environment. We also used earplugs. Some of us did. That was fairly popular. In terms of the sleep study, that was a project that was run by Kate Green. There were several objectives that she was investigating. One was that basically in an analog environment where you have a crew that's isolated from the outside world, how does basically being in that environment affect your sleep cycles? So before going into that environment, we each generate a baseline. We wore those sleep monitors at home for about 2 months, and that allowed her to compare our normal sleep habits to our sleep habits in the habitat. Another part of the sleep study was exposure to a bright light in the morning. It was a light that was specifically designed to essentially awaken, make you more alert. And it was a 2-week on, 2-week off scenario. So for 2 weeks at a time, we'd wake up and we'd have this device, basically like a lamp, that we had to shine in our face for 45 minutes. It wasn't as painful as it sounds, because basically you could just put it off to your side and you could read or use your computer while you get your light dose. And the results of this study are being evaluated right now. I know she generated a lot of data from 6 people over 4 months, so some interesting publications should come out of that.
Hi, first of all, thank you for this presentation. It was very, very informative. Going on what she said, did people go stir crazy?
No, not really.
And
first
fight
of all, yeah,
or get on each other's nerves?
Yeah, well, they selected the crew very carefully for compatibility. That was basically their primary concern. They wanted to select individuals who would get along with one another. I would probably say that was at the top of their list of criteria for crew selection. So they were very, very careful about selecting individuals who would be appropriate for that type of environment.
And I'm sorry, how long was this mission?
4 months.
4 months, okay.
Yeah, so it was 6 of us for 4 months in a fairly confined environment. We did not have very many interpersonal conflicts. We got along with each other really well. Maybe on a couple occasions, someone would raise their voice. That was basically as bad as it ever got.
Did you have a policy where if somebody was angry or irritated about something that you'd bring it to the table and work it out?
Yes, absolutely. Yeah, before the mission, we had a long list of topics that we discussed, and that was one of the things that we discussed quite at length. What if one person becomes a problem? What if one person either becomes angry once or twice, or is just consistently angry or unhappy with the situation? How do we deal with that person? So yeah, that was something that we were prepared for.
One of the polls, I believe, and a doctor ended up with cancer and they had to do surgery. In the future, do they plan to do that instead of flying someone out, take care of it right there and to...
Yeah, in fact, I remember that being discussed as something to investigate on these 3 upcoming missions. Telemedicine, basically having some kind of a setup where even if it's a significant emergency,
instead of
if
flying
it
them out.
could be handled internally, right?
Because it'd be very hard to fly them out from Mars.
Exactly.
Okay, and the last question is, you mentioned that there was one window for everybody to see out, or?
There was one porthole in the habitat, yes.
And did everybody have a time slot or to share it, to share that time out? Because it's very hard to be isolated like that.
Right.
And to hear everybody else's conversations and everything else.
Well, because our schedules were so busy, we really didn't have that much time to just stand and stare out the window. So people would look out the window for maybe 30 seconds at a time. So really, it was not a problem sharing that window.
Okay, we have time for one more question. Arrived at a station that was already built. Are there any experiments where you simulate landing in a rover and for a week or 2 you have to assemble everything and then live in the habitation? Because that's probably what's going to have to happen in a real situation when we fly to Mars or anywhere else.
Not that I'm aware of. My understanding is that the baseline plan for a Mars mission involves having a habitat basically ready to go on the surface of Mars before they even send the crew. It would seem a little dangerous to send a crew to the surface of a planet without a functional habitat already in place.
Okay, so let's give one more big round of applause to... Okay, and we'll have about a 15-minute break here, and then we'll have the Ignite talks. So stay where you are.